Okay, so I can just say if I take a plus b, okay, we have found out these two relations, so we are going to just use this. So if we take this, this and this gets added, this and this gets cancelled, so this is 2 times fc. Okay, you can do the maths here, there, okay, no problem, nothing. And then this side, what will happen, you have got AC, this is AC, this is minus AV, this is plus AV, so that will again get cancelled, so I'll be left out with 2 times of AC. So both sides we have got a C, 2 gets cancelled, so in general we can say whatever is A will be equal to F. So A and F are equal. So we have found out one relation, and we can actually use this result in C. Okay, so in C, let me say I'll use it in C. So if I use it in C, I will have it something like this: a square v square plus c square is equal to, now in place of f I can write down a, so I can just simply write it down as a square c square. Okay, and what we can do now is we can have c square on this side, this c square, and on the other side, this is also a square, this is also a square, so I can take a square common, and within bracket it would be nothing but c square minus v square. So we have a relation here almost done. Okay, we are aiming for a square, so I'll take a square on one side and the rest of the terms on the other side. So I'll take c square on this side. Okay, and on this side what I will do is I will take c square common, and within bracket I can take 1 minus v square by c square. I hope you understand this, because this goes to the denominator. I can take out c square so that I can cancel it out, and then finally I have the relation which is equal to 1 divided by 1 minus v square divided by c square. So I think if any of you even have remotely thought about knowing about Lorentz transformation, this is a very important relation. Okay, and this can be represented in different ways. Okay, so the end of it, what is the relation of a that we have? Because we are not looking for a square, we are looking for a. So that means it implies that a is equal to root over, right? So it will just become a root here, root over of 1 minus v square divided by c square. So this is the relation that we have. So once we have this, okay, we have already solved for a, and we know a and f are equal. So we have found out what is f and what is a. The only thing we are left out with is finding out what is d. Okay, so what we are going to do is we are going to derive for d. Let me just derive it here itself so that we have the relation for a ready, or maybe I can just keep, I think this, yeah, relations also, yeah. So if you check it, okay, if you check the relation number a we have, okay, we can again modify this and find out from a. So we can say that from a, okay, please write it down sequentially so that you are not confused. From a, see, this is your relation a, so from a we can have it as d square dc square plus fc is equal to a into c minus v. So we already have this relation. Okay, and here we can actually do our replacements, right? So in place of f, okay, I will just rub it. You can also, you don't need to write down an extra line. If you want, you can do it. In place of this f, what I can do is I can write down an a. Okay, and on this side you can have it as AC minus AV. So this AC and this AC will get cancelled out, and then I'll be left out with D c square is equal to minus of AV, or D is equal to minus of A into V divided by c square, right? But then what is a is this, so we can just replace it here, 1 divided by root over of, yeah, v square by c square, right? So we basically have got this particular relation, right? So that means for d also we have solved it. Let me just write it down in a more organized way. This is minus of v divided by c square. Remember there is a minus sign, so let's not mix that out. Divided by root over of 1 minus v square divided by c square. Okay, so this is the relation for D. Now we have got the relation for D, we have got the relation for A. We can actually now start replacing. Okay, so maybe I can take one more page. Okay, and here we will write down what is the value of A that we got. 1 divided by root over 1 minus v square divided by c square. What is the relation for D that we got is minus of v divided by c square divided by root over of 1 minus v square by c square. We also got a and f is equal, so that means a and f will be equal. And then we also got the relation for b, right? So if you remember, we have already done it here. B is equal to minus av, right? So that means for b also we got the relation. So b is equal to minus of av. So we have got everything, we have to just replace it, that's it. Okay, and where would we replace this? So the relation that we are going to replace it in is this, right? So you have got your first relation, that is relation 1, and relation 1 implies that x prime is equal to a into x minus vt, and a we have just now found out, so it is x minus vt divided by root over 1 minus v square divided by c square. So we have got the relation for x prime. Y prime is equal to y, nothing changes. Z prime is equal to z, nothing changes here either. We are just looking for one more relation, which is t prime. So t prime is equal to dx plus ft, and our d is here, so we can just write it down as minus of v divided by c square divided by root over of 1 minus v square by c square into x plus f and a are same, so it is 1 divided by root over of 1 minus v square by c square into time. So we can do is the numerator is the same, the denominator is the same, so I can keep it like this. This is root over of 1 minus v square minus c square. Just to make it more arranged, I will bring t in front because we have minus in the second one. So t minus vx divided by c square. So we have got these four relations here. Which are the four relations I'm talking about? First is this, x prime is equal to this, y prime is equal to y, z prime is equal to z, and t prime is equal to t minus vx by c square divided by root over 1 minus v square by c square. These relations are called Lorentz transformation. So you see, whenever we are basically going to consider a speed of light, we do have a change in the relation for x and y, x and time. Okay, and when we actually put it there, we found out the result. This is called Lorentz transformation equation. You have to remember this. This will be a 5 to 8 marks question, definitely descriptive, but if you understand what are the events that you have to consider, you can definitely do that. Okay, there are a lot of notations which are basically used. If you check any book, many books, you will find out that they have written V by C as beta. So V by C can be written as beta, and also gamma is actually nothing but this 1 divided by root over 1 minus v square by c square. So don't get confused. Even if I'm asking you a question where I write down that show that x prime is equal to x, okay, so what does it mean? It means that you can have x prime is equal to x, or I can write down directly gamma into x minus vt. So don't get confused, gamma means 1 divided by root over of 1 minus v square by c square. Okay? So you can take this, and t prime similarly can be written as gamma into t minus vx by c square. So I'm not considering beta, because if I take beta, I have to write it down as x minus vt divided by root over 1 minus beta square. So that can also be a notation. So any of these notations are being followed. So you have to just take care. Okay. So if you check any book, most of the times you'll see that these books are using the notation beta and gamma many times. Okay. So please make sure you follow that notation. So I'll just keep this as a note. Okay, so that's Lorentz transformation, and it's just numericals. Okay, it's just a numerical calculation analysis. You have to just consider certain events, and based on that you can find out Lorentz transformation. But then if I basically have a condition where I will be having a motion which is comparable to the speed of light, or I have a relation which is the speed of light, how do I show that this is invariant under Lorentz transformation? Okay, so not to make you more confused, I'm just going to do one numerical problem, and based on this I'm going to give you a problem which will basically solve. And the questions which will come in numerical would be like this: under Lorentz transformation. Okay, Lorentz transformation. So these questions are expected. Okay, so please don't ignore important application. I have to give you some problems, so this is actually an application part. X square plus y square plus z square minus c square t square is invariant. This is the question. So it says that under Lorentz transformation, that means whatever relation you have for Lorentz transformation, you have to use it and show that this is invariant. So it means that the final result that you are going to get, okay, should be invariant. Okay, so that is important. Okay, so before I do it, just give me a moment. So think about this question, okay, and try to answer it. Okay, how will you show it to be invariant? It simply means that if you take the prime coordinate, under the prime coordinate, this is basically going to be 0. Sorry, not 0. X square plus y square plus z square minus c square t square. Okay, to be equal to x prime square plus y prime square plus z prime square minus c square t prime square. If you can actually show that using the Lorentz transformation relation, you are basically going to say that this is going to be invariant. Okay, and this is what we are going to do now. Okay, so let's try doing this. Okay, you are going to get similar problems. A relation would be given and you have to show its invariance. Okay, so what we are going to do is something like this. We are going to write down this as x prime square plus y prime square plus z prime square minus c square t prime square. Okay, we are going to just take it in the primed coordinate, and we are going to do our maths and going to show on this side after Lorentz transformation that this relation is equal to this relation, and that will lead it to invariant. Okay, so I told you in the last class also what is meant by invariance. It means it doesn't change whether you consider the primed system or the unprimed system. So in the unprimed system, this is the relation. So in primed system also, this should be the relation. So let's just start from the primed system and then start replacing. So x prime, we have already seen what's our relation. Okay, so maybe I can just write down this. So x prime is equal to, I'll just just to make it more organized, I'll just write it down in terms of gamma. Okay, so gamma into x minus vt, that's the relation between x and x prime. square. Okay, we have seen in the last slide, already told. Y prime and y are same, so I'll just keep it as y square, and z prime and z prime are same, z are same, so I'll keep it as z square minus, and then you have got a c square here, so I'll just write down c square, and then we have got the t prime square. So t prime means this is gamma, and this is t minus xv divided by c square. So this is something which we have already done, so I will keep it like this. Okay, उसके बाद we are going to take y square plus z square, y square plus z square. Okay, and then we are going to combine these two, right? Now for both of them we can see that the denominator is same, which is nothing but gamma square, so we can take it to be plus. We're just going to keep it as gamma square. ये वाला no issues. We're going to expand this x minus vt, right? So if we do that, this is nothing but x square minus 2 times x vt plus t square. You can do it on your own also. Okay, so this is plus. I will just keep on doing it, you also do it, and we will arrive at the same result. V square t square, this is there, and then there is a minus sign, so I'll just take this as minus c square, right? Gamma square दोनों के साथ है, so let me just use this bracket, and then I'm going to expand this. This is t square minus 2 times x vt divided by c square. Okay, then plus x square v square by c to the power 4, right? Just squaring, that's it. So यहाँ पे हो गया y square plus z square, and then we are going to just open the bracket, and we are going to check that many things actually gets cancelled out. Okay, so let's just open the bracket. This is x square minus 2x vt plus v square t square minus c square t square minus this is what I will take this first, maybe, or maybe I can take this also. Let me take it as plus 2 times of x vt. This c square and this c square will get cancelled, and then minus the c square and c to the power 4, so this would be x square v square by c square, right? So if we do that, this gets cancelled with this. Okay, and what else? Okay, so that's it. Okay, so itna hi rahega. So this is plus z square and plus now gamma square. So gamma is 1 divided by root over of 1 minus v square by c square. So gamma square would be nothing but 1 divided by 1 minus v square by c square. ठीक है, ये तो हो गया. उसके बाद यहाँ पे you can take common. So if we take x square common, see this is an x square here, this is an x square here, so I can take x square common here. So this will be 1 minus v square by c square. I think you can guess what we are going to do now. T square is common, so I can take again minus and maybe t square. So if I take minus before, so this would be minus c t square, so I'll take the c square, and then this is minus of v square, right? Now I can take out c square from this, so I can just have t square c square. Okay, so if I will do it in this step itself, okay, I think this is clear to you. So यहाँ पे मैं क्या करूँगा, I will take out c square, so I will take out c square. If I do that, I will have 1 minus v square by c square. I've got 1 minus v square by c square common, so I can have it as y square plus z square plus, and this is nothing but 1 minus v square by c square into, and I can take 1 minus v square by c square common between the first term and the second term, and I'm left out with x square minus c square t square, right? So it's simple now, it's cancelled out, right? And then I get what I need. So this is nothing but, this is the x square minus c square t square. So x square को पहले ले लेते हैं, x square plus y square plus z square minus c square t square. So you see, you have got x prime square, y prime square, z prime square minus c square t prime square, same as x square, y square, z square minus c square t square after the transformation. So if this happens in whatever relation is given to you, you can simply say that this is invariant under Lorentz transformation. So this is very simple, a normal algebra. Okay, you have to just maybe a 2 marks or a 3 marks question, not beyond that. You have to just remember what is the relation between x prime and x, t prime and t. Baki sab to same hai. And then speed of light is same in both the frames, so c and c prime is meaningless when we understand what is relativity, right? It's c is here, c is here, so that's it. So you will actually get these kind of problems. Okay, just make sure that you understand them and do it. Okay, so ये इसमें कुछ करना है नहीं खास, you have to just use it correctly, these relations. That's it. Most of the times when you get a question, it will be invariant. Okay, you have to just check. If there is a speed of light involved, it will be invariant. So this is invariant. I will give you one more problem, okay, and this time I am expecting that you can actually solve it, because I've already told you how to do it. Okay, so the problem is something like this. You can try it now. Consider two events. Consider two events. Okay, what are those two events? Let's see. This is x1, y1, z1 and t1. So you have got a frame of reference where there are two events happening. Okay, it's not that just one event. We have got two different points where there are two events happening. Maybe there are two light bulbs which starts flashing. Okay, so that's there. And the second one would be at the point, let's say x2, y2, z2, t2. So please understand the question. Understanding the question is very important. If you get the question, I think it will be more easy. Technique I've already told you. And then this is x1 prime, y1 prime, z1 prime and t1 prime. Okay, and this is x2 prime, y2 prime, z2 prime and t2 prime. Okay, so we have got these two events, and then the question is, then check this out. Okay, this is something which is again something similar. x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square minus, so this is something which is similar to the previous problem. The only thing is you are having a difference between two events here, t2 minus t1 whole square. Okay, this is basically invariant. Okay, so this entire term is actually called interval. Okay, interval between the events. Okay, so is, okay, maybe I can write down, I complete the question, is the interval, because you are taking out the difference between x2, x1, y2, y1, z2, z1, is the interval between the events is invariant under Lorentz transformation. So that's the complete question. You have to solve it. So I'm not doing it. Okay, I just want you to do it. Okay.